This is Algebra 1, Lesson 15, Practice Problem D, Surface Area of a Right Solid. A base of the right solid 10 meters high is shown. Find the surface area of the right solid. Dimensions are in meters. Remember that the lateral surface area of a right solid is equal to the perimeter of the base times the height. Okay, so they're giving you a little reminder of your formula. They're saying lateral surface area is equal to perimeter of the base, and then that's going to be times the height. Okay, and the perimeter of the base, here's our base enlarged, would be all the way around, and then you would multiply that by the height. Okay, now what does this shape look like? This was kind of hard to draw. Sorry, that's not the best drawing, but I did what I could. Okay, feel pretty good about this one. Not so great about this one, but you get the idea. It did make me think about those shape sorters that little kids play with. I had to get us a picture of it. Okay, that's what this shape made me think of. Is, you know, sometimes they'll have these. I mean, some of them are shapes we've seen, right? We've got this rectangular prism here, but then you have these weird little shapes like that. These are all geometric shapes. Do you remember playing with those, or know anybody who played with those? Well, that's what this reminded me of. This would be a three-dimensional geometric shape here. All right, so now we've got to figure out, what are we going to do? Well, I always start with the base. So we find out what this is, and we know that there's also that down here on the bottom, okay, that we can't see unless we tipped it over. And they were nice enough to give us an enlarged view of that. So let's find the area of this base. So that's going to be the area of the base. Well, we're going to have to find it in parts. First, we see that we've got this triangle, and then we've got this semicircle. So let's try to get both of those. So the area of the base is going to be, first we've got the base of the triangle. We're using the base twice. So we've got a base of the geometric solid, and we've got a base of the triangle. And it is going to be 8 times the height. Well, what's the height? Is it 10? No, because it's not perpendicular to the base. The height has to be perpendicular to the base. And here's a perpendicular line to the base. They show us that, right? We don't lean when we get our height taken. We're going to stand straight up. If I know that this is 3, that means this is 3, and that means this is 3. So if those are 3, then that means this total is going to be 6. So the base is 8 and the height is 6. And then that's going to be divided by 2. That's going to be 8 times 6 divided by 2, area of that triangle. But we're going to need to add to it the area of this semicircle. So we're going to have to divide it by 2 as well. What would be the area of that circle? Well, it's going to be pi times the radius squared. So we're going to have 3.14, and our radius is 3. Okay, now this is one base. Okay, let's make sure we got all our parts. We have this semicircle, and here's our whole circle, but divided into 2 makes it a semicircle. And then we have this triangle, which is base times height divided by 2. Okay, so now when we take those, and then we're going to double it. Let me use some brackets here. Why are we doubling it? Well, because we have this base up top, and we have this base down to the bottom. So that's one area that we're going to have. And then we're going to have to get the lateral surface area. Okay, I think we'll do that separately. So let me unmark all of this, make it less confusing. So let's do this. Let's go ahead and compute these. So we've got 8 times 6 is 48 divided by 2, plus we're going to do 3 squared, which is 9 times 3.14, and then we're going to divide it by 2, and then we're going to put all of this, we're going to double it. 48 divided by 2 is 24. So we're going to have 2 times 24 plus, and then we're going to compute this. Let's do that. 9 times 3.14 divided by 2. That's 14.13. Okay, now we're going to add those together. So that's going to be what? 38.13. And then we're going to double that. And then that's going to be 76.26. And we know that's area, and our units were going to be in meters. Ooh, this is large, right? So that's square meters. And that is just the area of the two bases. So we're going to have to add to that lateral surface area. So remember, we talked about the lateral surface area. We could cut it up, or we can just merely, I'm going to change colors. We're going to think about the perimeter of the base, because that's what it would be if we cut it up. It's going to be 8. We know we're going to have to add this 10 to it, and then we're going to have to find half of this circumference if we had the whole circle, because we really only want this piece, right? So let's work on that. Lateral surface area, we're going to have the 10 plus the 8 plus the circumference, half of the circumference of the circle. So let's go ahead and show that we're going to divide it by 2. Circumference is equal to pi times the diameter. The radius here is 3, so the diameter would be 6. So that is going to be pi times 6. And we could, I should have, I guess, gone ahead and said that pi would be 3.14. Okay, so that's 3.14 times 6. I think I'm going to go ahead and put that in parentheses so it doesn't look like another decimal. And then we can compute this. Now, before we add it all up, let's do 3.14 times 6 and then divide it by 2. Did you get 9.42? Okay, and then we're going to add all of these together. Here we get 18. And then here we're going to get 27.42. That is not the area, okay? That is just that distance all the way around. So that is this distance, the kind of bluish that I highlighted. Okay, so this is not area. This would be in meters, that distance. If you were a bug here and you crawled from here to here and around here, that's the distance. Now remember that what we're doing is, if we unwrapped that, that would be this really long rectangle. And the top of this rectangle would line up with what I just highlighted there. Okay? Well, how tall is this thing? Well, it tells us that it is 10 meters high. So that means that this distance here is 10 meters. And this distance here is that 27.42. So we're going to find the area of this whole thing. We'll use a different color here. This whole area is going to be the 27.42 times 10, which is going to be 274.2 square meters, because you're multiplying meters by meters. So now we have that lateral surface area, and we can add these two together. When you add the two together, when you add this number plus this number, you get 350.46, 350 and 46 hundredths, and that is in square meters. And that is your total surface area for this figure here.